Hi guys, in this video, let's look at what React Query is and how it is helpful for us to improve the data fetching performance. We have recently integrated React Query in a couple of Neat applications, and Neat AB was one of them. So let's take examples from the Neat AB. We have two different tabs, one for the listing of articles and one for members list. In the straightforward way, how we implement this, we'll be fetching the data from the server in a component mount lifecycle, and we'll be having a local state which represents whether the data is getting loaded or not, and there will be another state where we keep all the data fetched from the server. This will be similar for all the components. For the members as well, there will be a state indicating whether the data is getting loaded or not, and there will be a data to store all the members. So this thing is similar for all the components that has data fetching logic. So maybe we can extract this particular logic of data fetching and keeping that in a particular state with its loading states and stuff. It will be better if we can extract this to a reusable hooks that we can reuse across different components. Also, if we are to store these data in a local state, every time uh, we every time these components get remounted, for example, while switching the tabs, the previous data will be destroyed and new data is getting loaded from the server. So this is happening over and over whenever we switch the tabs. The data is not actually changed. We are fetching the same data from the server again and again. That is a little uh, redundant. So instead, maybe if we can implement some kind of caching techniques, for example, maybe we can use a context that stores all the values fetched from the server, or maybe we can use an external global store like Redux that stores all the API related data, and these components can share that data so that the data will not be destroyed when the component is getting unmounted, and when we are going back to that component, that data can be fetched from the store and can be displayed here every time we are not fetching the data. And this is exactly what the React query is doing for us. React query is actually a small collection of the hooks for querying the data, updating the data. In case of querying the data, we we have a use query hook that has a loading state, a state that contains data loaded from the server, and a couple of other attributes that are helpful for us. Also, there is a hook for mutating the data in the server. It is called use mutation, and that's what we use for updating the data in the server. For example, the post request, put patch, all those kind of requests are handled by the use mutation hook. Let's look at few code samples. We are making use of the use query hook that is available from the React query to fetch the data from the server. And the signature of the use query hook will be the first argument of this hook is expected to be a plain string or an array. This array can have different kind of elements inside it. It can contain a string, or it can contain objects of different shape. So this is a query key. This can be string or array. And the next function is a function that returns promise. Once this resolves, we are expecting the data from the server to be returned. And these are the third argument will be different configuration options. For example, we have provided here the stale time for this particular query. That means after the stale time expires, the React query needs to invalidate this particular query cache automatically. So what React query will do is, until and unless the stale time is not expired, whenever we call this particular query, whenever we run this particular query, it returns the same value that is there in the cache. It doesn't make any network requests because the data is not marked as stale. There are a couple of different other options here as well. For example, we can pass a select option which can take the result data and transform it to some other format. Maybe this can return data. We can do all the transformation that we need so that the result data will be passed to this particular function, and that's what will be returned by the useQuery hook. The return values will be having, for example, these are expected to return is loading state, which represents whether the data is being fetched from the server or not. And there will be a data. This data variable will be having the data resolved by this promise function. And there are a couple of other useful functions here as well. For example, if fetching is there, and we are calling this use fetch articles inside the component. Here it goes. We are getting the data and is loading state. See that we have just called the useQuery hook. We don't have any other states for handling the loading state or storing the data from the server. It is all handled by the useQuery hook. And also the internal caching techniques are also handled by the useQuery hook. We didn't need to specify any reducers or actions like we do in the case of Redux and some other things. The benefit of all this mechanism is that when this articles component renders, first it will go check the React query cache, whether the cache is already present or not. If it is already there, we are rendering the component from the cache to data. Then that will render faster. We don't need to wait for any API requests. Whenever we call the useFetch articles hook, it will come here and the useQuery will match the given query key with all the available query keys in the cache, and if it finds the exact match, then it will return the corresponding data if it is not marked as stale. If it is marked as stale, instead of returning the data, it will directly fetch from the server and return that data. One thing to note here is that every parameters passed here in the query key will be deeply evaluated, so it's not a shallow comparison, it's a deep comparison. And each change in these parameters represents a different caching instance. So the data corresponding to this particular query key will differ according to the parameters that we pass here inside the query key list. And after the stale time only, this will invalidate the previous cache and will fetch from the server. That improves our performance while switching the tabs. We don't need to fetch the same data again and again. For setting up the React query in your application, first you need to define a query client. In our case, this is done inside APIs folder. There you can see a query client file. This is where we are defining the query client. We are creating a new instance of query client with the default attributes for the query cache path. We are following this approach because in almost all the cases, while handling the API errors for all the API requests, what we are doing by default is showing a toaster with the error message. So instead of doing this for each and every query, we can define that here as a default error handler. So whenever a API request fails, this will be executed so that a toaster will be shown. And we need to pass this query client as a context value to the whole application. That is done where we are declaring the root components for the application. Here we have different context providers, and query client provider is one of them. This query client is imported and we are passing the query client instance that we created as a client. This is required because all the usage of use query and use mutation different hooks that are associated with the React query makes use of this particular query client. So if we haven't passed this and we are calling the use query hook inside a component, it won't be having the access to the query client instance and it will fail to work. And that makes this an important step. Another convention that we follow is for every related API request, we keep them in a separate file. For example, in the case of articles, we created a file called use articles API, and all the related queries are kept inside this file. The use query is used to fetch the data related to the article, and we have another form of hook called use mutation. This is used to update the data that is there in the server. For example, this is a mutation for updating the data in the server. The signature is more or less similar to the use query. We don't have a query key here. Instead, we'll be running a function directly, and this function is expected to return a promise. And we can also provide a on success and on error callbacks to do things that are done on the success of the API or on the failure respectively. In this case, when the API succeeds, we are invalidating the articles list. We are passing the article list API key to this invalidate queries function, so that that particular data will be marked as stale in the cache. So whenever we try to access that particular data from the cache, uh, since it is marked as stale, it will not be returned. Instead, the React query will fetch that data from the server and will return the updated data. There is another method which is called optimistic update, where we are not invalidating the query, but instead we are updating the cache with the values that are available to us. For example, what we'll do is, if we are, for example, in this case, if you have to make use of the optimistic update, what we'll do is we'll call the query client.setQuery data, and we'll pass a query key. Here it will be articles list, and the next function is an updater function, so that it gets a previous state, and we can filter the article ID that was deleted, and then we can return the new state from here. So when the API succeeds, we are not waiting for another API call to update the data in the cache, but instead we are just updating that data locally. This works in some cases, but if this particular query key is complicated, then this won't work for every cases. For example, if this query key list depends on too many attributes, for example this one, we are spreading all the properties here as payload. So this query key will have different many sets of attributes assigned to the query key, and in order to update that particular data here, we need to know all the properties associated with that key and its values to access that particular cache entry in the React query cache. So that will be difficult because it would have been changed a lot of times, and we are trying to locate that in the cache will be difficult. So what we can do instead is, for such cases, it's better just to call the invalidate queries function. Invalidate queries function matches the query cache even with a partial match. That means we don't have to specify all the query key attributes here. Just if we pass an article list, every cache entry that are preceded with this particular cache key will be invalidated. For example, suppose that we have two cache entries with the following query keys. When we call the query client.invalidate queries, and we are passing an article list, this will be partially matching all the query keys. So all this will be marked as invalid. From the changes so far, it must be apparent that the query keys need to be unique for each category. For example, for all the article related queries, we are preceding it with the articles list, and for all the comment related, for example, we are preceding all with the comments constant. And to ensure the uniqueness of these query keys and not to accidentally mix them together or duplicate them, we are now following a convention of keeping every query keys in a single file, so that we have a bird's eye view of all the query keys that we have defined so far. It reduces the chances for creating the same constant again. Now let's talk a little about passing the parameters to the API request. Let me show you an example for that. Suppose that Suppose that what we are getting from the payload is something like this: page and search, filters, so on and so forth. All these values could be dependent on the API request that we are about to make. This could be a query params for that particular request. It is necessary that all the values we pass as a dependent attributes to this function needs to be passed as a member of the query key array as well. This ensures that, like here, like this ensures that whenever any of this value changes, this particular API will be fired, and the new copy of the attributes will be passed to fetch the data from the server. If we are removing any of these attributes from here, for example, I have removed the filters, so this hook will not respond to any changes to the filter. That means all the API requests will have the reference to the initial filters, and this will fail to load the filtered data. So please ensure that all the parameters that the API request depends on is also defined in the query key array as well. Now I want to talk about the dependent queries. For example, suppose that I have a query here that fetches the user details from the server, and in the response I have an user ID, and suppose that for the article list API I need to pass this user ID as a param, and this is a required parameter, so without that the API should fail. In this case, these both APIs will be fired in parallel when the component mounts, but even before this succeeds, this will fail because the user ID will be initially undefined. We haven't got any user ID from the server yet. To handle this case, what React Query proposes is a configuration called enabled. So we can enable this use query hook to run if and only if the user ID is present. With this implementation, if the user ID is undefined, this will not work. This won't check for data in the storage. This won't fire any API calls. This particular use query hook goes in a disabled state, and once the user ID becomes available, this is automatically initiated and will be fetching articles from the server uh, with the user ID present. There could be different conditions here, and it differs with respect to our requirements. One thing I would like to add to this will be how the API exports are now structured. Previously, for the all API requests, we used to do the named exports. For example, let me take the articles API file. This used to be a named export for each and every request, but now after the React Query integration, we have changed that to a default export which contains all the API requests as an object, and we are importing that as a default import, and we are calling that as articles API.fetch articles, and so on. This is the end of this video, and I hope now you have a basic understanding of React Query, how to set it up, and that should help you get started. For more details on all the configurations, you can visit their official documentation. There are so many examples, and there is an exhaustive documentation as well. Also, Neato KB can be a good reference point. We have integrated React Query for all the modules, and everything is nicely stacked up. So this could be a good reference point. Thank you. Good day.